As we look at rate of change, sometimes we are given information that we must put on a graph. And there'll be times when we will have to determine two things. If the actual rate of change is constant, or if the rate of change varies. So, if you take a look at Bob's Burger, we have a table that's telling us that the cost of three of Bob's Burgers is $9. The cost of 6 is 18. The cost of 8 is 24, and the cost of 10 is actually 30. So what we've done, because rate of change not only it's going to come to us in a table format or a list of words, also we should be able to make that determination from a coordinate plane and a graph. So what I have, if I've graphed this information, and as you can see, I have my cost as my y-axis, and the number of burgers is my x-axis. And I'm doing so because the actual cost is affected by the number of burgers. So I'm going to make sure that I put here visibly for us that my number of burgers is going to be on my x-axis, and of course my cost will be on my y-axis. So I have again plotted this. X is 3, y is 9. We want to make sure that when we plot, that we always plot x first and then y in an ordered paired scenario. X is 6 and y is 18, and of course x is 8 and y is 24, and x is 10 and y is 30. Well, I think the first thing we need to do before we look at this is to make sure that we can develop our rate of change. So let's go ahead, remember what the formula is. To construct it, it says that it has to be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Well, let's go ahead and take a look at this with our x values first. This is the first, this is the second, so of course this is 3 from 6, that's going to give us 3. This is 6 from 8, that's going to give us 2. This is 8 from 10, and that's going to give us 2. Let's make sure we go down and look at the bottom ratios. This is 9 from 18, and that's going to give us 9. This is 18 from 24. This is going to give us 6, and then of course 24 from 30 is also going to give us 6. Well, now let's take the ratios. So again, we take the ratios of y over x. So we're going to take the ratio of cost to burgers. Okay, that's our y over x. So let's take the first one and see just whether or not we have a constant ratio. If we do, then we should have a straight line, and if not, it's still a rate of change, it's just not a constant rate. So let's see if we can come up with that. So here we have 9 over 3, which is reduced to 3 divided into 9. Then we have 6 over 2. When you divide, again, you'll get 3. And then again, we have 6 over 2, and when you divide, you'll get 3. So as you can see, our cost of burgers is a constant rate of $3 to one burger. Now, just another way for you to look at these. You know, we have just putting the ratio up and dividing, but we can also find the ratio of our x value, then the ratio of our y value that way, and then of course we can, and if it's constant, then we should have a straight line. So as I look at my graph, and I want to say, okay, I have to have a straight line because this is giving me a constant rate of change. And as I look at my graph, starting here, going all the way through, so this is telling me that my graph is going to give me a unit rate, and it's going to look like that, which of course is a straight line. So here's what we can say just by looking at the table and looking at the particular graph. We can say, let me go ahead and write this down. So from what we've seen, we can make a conjecture and say, if we have a constant rate of change when we graph, we will have a straight line. Thus, a constant rate of change is linear. And the word linear just means a straight line. All right, constant rate of change.